recorded.
Okay, it's recording, I think.
First thing I would like to show you, have you seen our page? That I cannot seem to find it right now.
I have the configure vision.
I think it's on this page, configure GitLab groups, configure groups. I think I'm on the right path. No. Jeez, where's this? GitLab configure. Stage.
Shall I ping you the one I have opened?
Yeah.
It's the vision, so maybe you can. Okay.
Yeah, that's a good one.
So I started reading this, but I don't know many of the things. So I need to dig each link and see what each thing means. Or maybe you can help me a bit.
Yeah, definitely. So I didn't find yet what I wanted to find. Let's see. Maybe the formal will work. Okay. So what is, I think this page is enough actually. I think that's the page. I was thinking about something else, but I think that's the one. So what, I think it's Daniel who speaks in this video here, and what he's showing basically, it's what features are the main features in systems that we control, and yeah, what's important to us, what's in our roadmap, right? So the main thing I've been working on with the rest of the team since January, that the most things that I see we work on, they are related to this Auto-DevOps feature, which I can do a quick workshop with you and show you how it works. But furthermore, when we talk about team configure, we're talking about not only this specific feature, Auto-DevOps, but we also talk about the configuration of Kubernetes. Then we have serverless, which is a different team now that's taking care of serverless. Runbook configuration, which is automating some steps, like we call it runbooks. It's here written, incident management. So usually in runbooks is like a set of steps that one needs to run or to execute, a set of commands to execute when things go bad, you know, so to work in an emergency scenario.
Right.
And then runbook is our way to automate those steps. So a person can come in and in an incident can just hit a play button and all the steps will be automatically run. So that's what we're trying to do with runbook configuration. And for that, we have an application called Jupyter Hub. I'll also show you this, that allows us to do this kind of stuff.
And by application, you mean it's a plugin, or is it
it's a plugin that we will install on top of Kubernetes? Right. I will show you this soon. So, okay, so let me try to speak quickly about each one of those features. So Auto-DevOps. This one we're going to go deep in detail because it's the one that we use the most, but what it is basically is the following. So first, when someone pushes code to GitLab, right, we can run some automated processing of this code. We call these jobs that runs on a pipeline. A pipeline is a set of jobs. And so it's basically like this. A developer comes in, edits the code, and pushes the code to GitLab using Git. And then GitLab figures out that there is a new code there. And GitLab will run a set of scripts inside of a job. Okay? So these scripts, what are those scripts? What are they doing on top of this code? They are testing the code, so checking the quality of the code, building the code and packaging the code with dependencies that the code needs to be run, deploying the code to a certain environment, let's say to a staging, which is a test environment, or deploying the code automatically to production. So these are all automation that we do on top of a code that has been pushed to the repository. This runs inside of a job, which is part of a pipeline. A pipeline is a set of jobs.
Can I ask a question?
Yes.
Is these processes that are run to package or merge the code in an environment Git or GitLab? So are they processes that have been written by other people for Git or GitLab specific?
It's not Git, the automation of those scripts. This is GitLab.
Okay.
So Git is only controlling the version of the code in your machine, in other developers' machine, and also in a server that gets all this code into this machine, right? Why Git is important? So Git can do things like, it allows us, for instance, for us to version our code. So Git is versioning all of the changes that we do to our code. This means that if we deploy something to production and it's broken, we can easily come back to the previous version, for instance. This could be a thing that Git would allow us. Other things are, it allows us to work on same features at the same time. So I might be working on a feature, on a file, on a certain file, and you might be working on the same file on your machine. But when I push this change to Git on the server, and you push it as well, we need to define what's the correct version. Is it your version that's the correct one? Is it my version? Is it a mix of these two versions that should be the one that's the final version? So Git's main responsibility is like taking care of the repositories and the changes that happens to repositories. That's why Git is for Git.
I see.
Solely Git, okay?
Can I ask, or maybe you will answer later, but before Auto-DevOps came in play, when the developers pushed a change, they had to manually configure all these dependencies?
So now it's a question outside Git scope, right? So
yeah, it's the
Git is independent from GitLab. You can have Git on, you don't need GitLab to have Git. You can use Git in your own server. If you would like to set up Git on your own server, you could, and everyone could use Git. And then when it comes to Auto-DevOps, what people do, it's like this concept of CI/CD tools. CI is continuous integration, and CD is continuous deployment, and or continuous delivery. I think it depends on the concept. And it's basically the idea that you can push your code to a server, to a cloud, and this server will be responsible for testing your code and fail and say, hey, you cannot deploy this because your code has failed. And furthermore, if it passes, then it will automatically deploy it to production. And then this like continuous delivery and deployment of your code, like that. The code just gets merged to the master branch, and then gets accepted if the test pass, and it gets automatically put live. So this is this concept. And across the year, before Auto-DevOps and even before GitLab, there were already many tools for you to do this kind of automation, where you can get the code on the server side, run tests on top of it, and and do this kind of automation. And but the thing is, at the time we had like one software that most developers used to use Git, a way to facilitate the use of Git, and also this creating merge requests, this kind of stuff. People were using GitHub the most. And then together with GitHub, they would need to have another system, another website where they can also automate this code. So they would create triggers to connect this other website. On this other website, you would create a list of scripts, and these scripts would do test your code, deploy your code, build your code, this kind of stuff. But they would have to connect to GitHub. So then you would have like two tools to do the main thing that you're interested in doing, right? And this is just one example, but in those scripts that you would be doing on this second tool, sometimes you would have other dependencies inside of there as well. Like for instance, to proper test your code, maybe you would need to check your code for security. You'd need like a third tool that you would have to connect to this tool, and then suddenly you have like a set of websites or systems or softwares that you are integrating together so that you can set this all up. And GitLab tries to solve the problem of being your single tool for all the DevOps lifecycle. When you say all the DevOps lifecycle, you say since you start planning your project, right? I think that's the first phase, when you start planning the idea of a problem, and then we have our boards that help you with this, and you can create epics. And then you can create issues inside of those epics. So for this, someone would be using, I don't know, Trello or Jira, yeah, any of those. And then there's another tool. So GitLab is trying to get all those necessities, all those needs that we have since management until going through developing and testing builds and building infrastructure. So that's another part of what we do. And then deploying and then monitoring after everything is on production. We also have to monitor the feature. So yeah, so we try to implement all of this inside of GitLab so the user has better, it's facilitating the user's life in just having everything out of the box in just one tool. It's easier to configure, it's easier to communicate, to sync between everything. That's the main goal.
Okay. Good. Good explanation.
Okay. And Auto-DevOps will become clearer soon when we start doing. But so Kubernetes configuration, when we talk about Kubernetes configuration, we're talking about the provisioning infrastructure as well. So not only you need those scripts to be set up, like I said, but we also need like to set up the servers, right? And we need to run those scripts in some machine. So where are these scripts going to be run? This automation is going to be run. Where is your site going to be deployed? So Kubernetes is helping with that. We are helping you to provision Kubernetes. That is saying, we are helping you to provision Kubernetes, which is a software that controls many servers. Let's say like this.
By servers, you mean containers probably, right? Or in machine instances, let's say.
Yeah, it's a container orchestrator, you're right. So you can have many containers.
But there is no OS running in the containers.
There is.
There is. Okay, but it's not, okay. So it's not a complete operating system, I guess?
So it's part of the operating system. So the container, it connects to the kernel level of the OS. So you have a machine, and this machine usually is running on Unix, yeah. And then the container, it is encapsulated, it is siloed in regards to the host that is hosting the container, to this OS, but it talks to the system on a very low level, you know. So it's like it's using the same OS that it's there, but it's siloed inside of the OS.
So a virtual machine contains piece of the OS inside the VM, while the container communicates only with the OS. Do I understand it correctly?
Yeah, I guess it's hard to explain. I think you got the idea. So the container is more connected to the OS, and the VM is more like virtualizing the resources into a new OS, like you could have, right?
But containers also use part of the CPU and the RAM of the host. So
they do.
Okay, so it's split among how many ever containers you have created. The resources of the host.
Yes.
Okay.
Definitely, yes. Okay. So Kubernetes is this container orchestrated, and it will help us to create. We can create a cluster of machines that have Kubernetes on it, and then Kubernetes has some more abilities in regards to controlling the versions of what you are deploying as well, controlling releases, scaling your application. It will help you with this as well. Yeah.
If I can go back one step, when you say Kubernetes provisions the machines,
this was a false statement. Kubernetes does not provision the machine. I think we provision the machine with Google Cloud API. So that's how we provision the machines.
Okay.
Kubernetes not provisioning the machines. Yeah. Okay. What GitLab provisions is more process for your system, maybe. So we can say to Kubernetes, there's a possible configuration where you can say provision just one process of my website, and then if my website starts to use more than 25% of CPU, then provision another process. So that's what Kubernetes is capable of doing.
I see. So you can have it completely automated, or you can say specifically what resources you wanted to use.
Yeah, it can be both ways. You can have it automated, where Kubernetes can identify that this happened and work by its own, or you can implicitly say to Kubernetes, please scale up or scale down. You can also do that.
Okay. And maybe I'm getting too much into specifics. So if I do, tell me and we continue with the next thing.
Mm-hmm. Yeah, I think it's interesting that you are interested about it. Yeah, just keep asking questions. I think asking questions is never bad, okay? Maybe it is too much right now. Maybe you won't make use of this knowledge right now, but it's good that you're asking. I think it never hurts. Could be that in some communication, by you having this kind of knowledge, it might help you understand what we are talking about.
Cool. Thanks for answering all the questions.
No problem.
So
and serverless, can I move to the next?
Yes.
And serverless is basically it's a resource that we install on Kubernetes that allows Kubernetes the ability to scale down to 0. So this means that if you heard about the functions and like Lambda, AWS Lambda, this kind of stuff. So what these things are doing is basically the following. You have like a microservice or whatever that has an endpoint, and then you hit this endpoint to get a response back, right? And let's say this service is consuming some CPU and memory because it's running on some server. But if this function or service does not get any hit after so many minutes, something like that, then it can be like turned off. So you can like save on costs for keeping those things up. So serverless is about this. It's about this kind of technology that we install on Kubernetes, and then Kubernetes starts being capable of dealing with these things.
So again, you have dependencies a bit less. Yeah.
Yeah, we have a dependency here, which is Knative. That's what we use on top of Kubernetes to allow Kubernetes to be serverless. You don't need to use Kubernetes when you talk about serverless. There are other things that are serverless besides Kubernetes. Like I said, AWS Lambda is one of us. You also have functions on Google, on Google Cloud. But one of the advantages of using Kubernetes as your serverless architecture is that Kubernetes is cloud agnostic. So this means that you can install Kubernetes on Google, on Amazon, or on Microsoft, and you can have your functions deployed to any of those clouds, and it will work the same.
Right.
If you use AWS Lambda, then your deployment's like strict to AWS Lambda, for instance.
And same with Google Cloud, I guess. So you would have to write one for each cloud.
Exactly. Or at least one deployment, something like that. So Runbook I've already talked about. Chatups is basically allowing for one to send commands on Slack, and these commands can trigger automation on GitLab. So you could say like I don't know the commands because I never worked on this, but let's say / create merge request and then pass title and description. And then you do this on Slack and it would create a merge request on GitLab, this kind of things.
Nice.
Yeah.
Seems like a big piece of work.
I think it is, but we haven't been touching this too much. I don't know if it's already very advanced that it doesn't need, or it's just not prioritized at the moment. But we have something already here that's working. So platform as a service. This one is the one that I get all confused about. And yeah, it's tricky. And there was already some discussion even between Daniel and Dylan to define this term better. So I would not try to explain too much here. Maybe I'm not the best person to talk about platform as a service because I might give you the wrong hints. I would go directly to Daniel or Dylan and try to ask them about it. Chaos engineering, as far as I know, we haven't started this yet, but the idea here is that this was a concept that was created, I think, by Netflix. And is that we have a bot or something like this that randomly will at some point in the month, it will trigger a set of breaking things in our servers. And the servers need to be able to recover automatically, or at least to get into a state where they are resilient, to use the word that's used here, and try to fight back this chaos engineering. It was called Chaos Monkey on Netflix. So it was like you leave like a monkey inside your server room, and it starts doing like all those crazy stuff. So it's like a test for how well your servers like are prepared for when real incidents happen. The idea is that as earlier that you know that if something bad would happen, if you know that what could happen with your service, if you have this idea, by the time that it happens, you already know what to do and you're better prepared to deal with the real case scenario.
Right. So it's like testing, essentially, but automated. And
it's testing. It's a kind of testing your infrastructure, yeah. And cluster cost optimization, I think it's self-explanatory, maybe. Trying to cut costs on cluster.
What's the difference with serverless?
Serverless is a way of doing cost optimization, you're right. So yeah, we haven't discussed much this, but user analysis of your infrastructure. Maybe we want to give more
advice.
Yes, analysis on what we are provisioning and say, hey, we're spending that much on this and that much on that. But we also talk about automatic resizing, which serverless comes into play. And we recently added HPA to Kubernetes, which is horizontal pod autoscaling, which is that feature that I was talking about where Kubernetes can scale up and down your number of processes.
Why is it horizontal?
Horizontal because when you add processes, you're scaling horizontally. When you add machines, you're scaling horizontally because you're adding on the same level. If you put more CPU to your servers, then you're scaling vertically. So if you add CPU or you add memory, you are scaling vertically, but usually you have a limit to that. You cannot scale that. You can only scale that far. But horizontally, you can add another machine beside the first machine, right?
And you don't have a limit to the machines you add.
You can, the limitation is the amount of money you can spend and the network, of course. So you'd have to start, you have a bandwidth. So if you have all your machines on the same region or same cluster, then of course the network's it's kind of closed.
Faster.
Yeah, you need to spread it around the world, but you see how easier it is to scale horizontally than it is to scale vertically. Okay. So that's
sorry, also not really worked out, the cluster cost optimization.
Not really worked out, you mean?
But
yeah.
Okay.
It hasn't been clear to me, like, if we are actually attacking this as our priority. We could check vision and see what it says.
I have to read all that. Maybe.
I never read it.
Okay, maybe then Daniel can explain to me.
Yeah. You see, there is like only one issue that's labeled with a cluster cost optimization.
Right.
And it's in the backlog. So I think it's not prioritized, or we're not labeling properly, I'd say. But Daniel might be, for sure, he's the better person to answer this. He will know much better than me. So I think that's an overview of our features. So like I said, those three are the most important ones, I'd say so, as of what I've been seeing since January, at least.
And relevant question for me and Tori. Well, Tori until she leaves. How much UI work and how much maybe experience work do you think is involved? For example, for configuration of Kubernetes, does this happen on the Kubernetes side or on GitLab side, and then GitLab sends to Kubernetes?
Well, I don't know if I know how to answer exactly your question, but let me try. So first, I gotta say that I think Tori has been pretty busy. Like, so there are many merge requests that require her attention. So probably you will be busy as well. And I think this at least I can say in regards to Kubernetes and Auto-DevOps. In regards to serverless, I've been a little bit away from it. So I don't know if there has been many front-end changes and yeah, so UX changes. I can see many back-end thing going on here, but I don't know, maybe there is. And then maybe the product manager there would know a little bit better, which is Nicholas as well. Maybe he would know the amount of work that's on the roadmap for UX here.
He's new, right? He's
new as well. Yeah, that's true. So maybe Daniel would know as well for now. But yeah, every now and then I can say that there's always something coming up for these two features.
And how much do you work with UX when starting the conversation of how you're gonna implement it, or do you ever speak with Tori, or is she mainly front end?
I don't take decisions on UX, my zero, so I can only suggest, and usually I can say that I often ping Tori about asking what's the best way to do. So that's how I've been doing. So there is an issue about, and usually, so if the issue is on a very early stage that is still being planned, then yeah, some developers might come in and just put some concerns. And I often see Tori, she already knows or has a very good idea on if that issue will require some UX change or not. She's acquired like a very good understanding on when that's necessary. And then usually she will prepare if we groom the issues on our groom meeting. And then usually it becomes clear if it will need UX or not, or it will happen asynchronously throughout the issue conversation. And then as I can see, we mark if it's necessary, we mark the issue as UX labeled. And then there is a UX ready label that's, I think Tori puts that on once she creates the screens that she thinks are necessary for the change to happen. But it can happen as well that throughout the course of the development, I might feel that this change, this whole change, how it was planned from the beginning, might show some complications. And then maybe I ask Tori if we can do this like split in different changes and then like do smaller changes and change a little bit the UX for that issue. This can happen. So on the fly, it might happen that we think, oh, can we break this a little bit, or do this UX in a little bit different way just because this would facilitate the backend or the front end. I don't know. So yeah, we are usually communicating well in the issues, I'd say so. So
you you collaborate. I was just curious of the process because some companies don't involve UX at the beginning of backend work, and they only bring UX in before front-end work. So I really like working with backend engineers as well. So that's why I was curious.
So now I understand better your question. So I'd say definitely we are talking a lot, and through these grooming meetings and discussing through the issue on early stages. And I think this is very important because, if UX would come later, it might come with an idea that for the backend developed solution, it could not fit, I think. And the other way could be also true. If the UX would simply put the UX on the screen, then it's most likely that we will also say sometimes, hey, this is not doable because this and that. So I think doing at the same time makes a lot of sense.
Exactly. That's why I asked. Exactly. Cool. On your point.
Happy that you're happy. But if not happy with anything, also, you're very welcome to raise any concerns and we can discuss some kind of thing. But okay, let's hit to the Auto-DevOps, just so we can have an idea on this main feature. And I can mainly tell you about some screens that I know that had UX working on configure side, I guess.
Right.
Okay. So I'm on my GitLab page, right? Nothing, gitlab.com. I'm going to create a new project. And I'm going to create it from a template project, which has already code.
Nice.
So I will use Nodejs.
What is Nodejs? Or is that what I installed as part of Git?
Nodejs?
Yeah.
If to install Git, you don't need to install Nodejs.
I installed whatever the instructions told me, so I ended up installing twice. Homebrew, for example, and Mac ports that I was told do the same thing.
You usually need to install Node.
What does it do, though?
Node?
Yeah.
So Node is it's a JavaScript framework language. I don't know how to call it, what they call themselves. But Node.js is JavaScript or Node running on servers. That's a JavaScript for servers, let's say like this on the simplistic way.
Okay, thanks for answering that. I need to do a bit of reading there.
Take it as a language, and it's language that's going to run on the server side. And Express is just the framework, actually. The web framework is Express. So I would say Node.js, the language, and Express, the web framework. Auto Node. Okay. Creating the project. So this will already give me some code that we can deploy. And if we would, so I was talking about jobs and pipelines, right? So no job has been run here. This code has just been added to the repository. And if you go to CI/CD pipelines, we won't see any job here. And that's because GitLab will only run those scripts that I talked to you about if there is a file here called .gitlab-ci.yaml. If we create a file here, we say new file, GitLab would even like has a template for it to see. You can say GitLab CI.yaml. We could apply the template for a certain language, let's say Node, because we're using Node, right? And this is an example of what a set of scripts that would run on a pipeline would look like. I don't like this example very much. Let me try to open another one that has the stages defined. So maybe. Okay, anyway, yeah, so this has the stages as well. So for instance, what this script says. The script says, use a Docker image to run this pipeline and use the Ruby image, an image that has Ruby 2.5 already installed in it. So this is Docker, like Docker file syntax, right? A little bit like. And then, yeah, here I define some services that I say they are dependencies for my project. Mm-hmm. I can specify some variables, some environment variables. I can set a cache volume so that I can run my jobs faster. Once the job runs one time, the next one will run faster because it was already cached, some of the things. And here I'm already saying, hey, the first script that you need to run is this before script, which is check the Ruby version, so see if it's correct, install some dependencies on this Docker container, and then I have some stages. So Rubocop is a stage that will run. Rubocop is a tool that checks for linting the project, the code. It will check for the quality of the code, let's say like this. On this script, I will run the specs. Do not get too much attached about all of this. You don't need to get in too deep about this, but I'm just showing you that this is a set of jobs that one would need to write manually to define per project or for their own project what they want, if they want to test what they want to do, because this is just a template, but might be that for my company, this template is not useful. So I need to write my own set of scripts, right?
Right.
I want to use the template. Yeah, go ahead.
This is like the guide for the machine, what it's gonna run from your image?
Yeah.
Okay.
It's the guide that says, whenever something changes, whenever a developer pushes code to this repository, run this set of commands, right? Like I said, view the code, test the code, deploy the code.
Right.
Right?
And this is CI.
This is CI. This is all of this is the concept of CI, doing this automatically, continuous integration, right? But this is very basic answer to continuous integration. I would encourage you to go and read a blog about it. There are plenty of blogs talking about it.
Cool.
In more detail. So, okay. All right. So we don't have any jobs running, right? And the thing is, so what Auto-DevOps will do for us is to create the best practices for what my pipeline needs to be. The best practices are really big. There are a lot of stuff that would need to run on your application for you to go through the best pipeline you can until you deploy your application. And you're going to see this soon. So what I can do, if I don't know much about the whole DevOps lifecycle, I can go ahead and I can hit on Enable Auto-DevOps right here. Mm-hmm. I'm going to say default to the Auto-DevOps pipeline. And then it says to me that you must add a Kubernetes cluster integration to this project with a domain in order for your deployment strategy to work correctly, right? So I'm going to save the changes. And I'm going to add this Kubernetes cluster integration that it's talking about. If I click here, I would go to the manual that describes how to do it, but you can also, I will directly do it. So go to Operations, Kubernetes. And I'm going to hit Add Kubernetes Cluster. And I have the option of adding a new cluster using my Google account, if I have a Google account that connects to GCP, Google Cloud Platform. So I would say, what's the cluster name that I want? What's the environment, if it's staging, production, all the environments. GCP has a set of projects that I am subscribed to, that I have the permission to create clusters on this project, on a GCP project. So I would choose which project I want. Which zone? So I want the cluster to be closer as possible to the users. If my users come from Europe, I would say Europe, or US, then I would check US, right? the number of nodes, the number of machines, let's say, or virtual machines that would be present on my cluster, right?
And you pay for those, right?
We pay for those, yes.
This is where you get charged from.
Yes, we get charged here, for sure. And also the amount of CPU, so how vertically scaled is this machine? So if I have a 16 CPU machine, and how much memory, 160 of memory, this kind of stuff.
Right.
But I'm going to, I think, do I have a cluster already created? I don't. Okay. Then let's go through this. Because if you had already a cluster created, you could add existing cluster, and then you add some information for a cluster that's been already created. Since I don't have it, I'm going to do the steps here.
So if you had a cluster that would be on all the time, and you would run, you wouldn't necessarily run all the time something, right, on a cluster?
Can you try to rephrase your question?
Sorry. So if you have an existing cluster, you don't just delete it or after you're done with the job, or just...
If I'm testing as a developer?
Yes.
Mm-hmm. So I usually delete it because I don't want my, because as you said, we are paying for clusters that are alive.
Okay, so if, in this case, if you have an existing cluster, that means it's running some job already and you use it?
Like, for instance, we can see here that Tekua has Tong, he has some clusters here, and Tong is sleeping. So I doubt that he's using all of those. So Tiger's also probably sleeping at this time, and he also has a cluster. Tori has a cluster. I don't know if she's working or not. It doesn't mean that the job is running at this moment. It means that the cluster is provisioned. The cluster is ready.
So you have kept these resources for yourself, and you're...
Yes. So this amount of resources.
And you keep being charged for them while they're up.
Mm-hmm. So we are now provisioning this cluster, right? You can see here, that's the name of the cluster that I gave. Mm-hmm. So usually when we are adding a cluster, we are also giving a prefix with our first name or our handle, just so we know who is responsible for that cluster. Because if we want to clean our servers, and yeah, we can talk to whoever created them and check if we could delete it or not. So this page changed a little bit, seems like, because we had this loading here already, but I could already see some things below, and now I don't see it anymore. I don't know if this is a bug or if this was a decision. But let's wait. So it takes about 5 minutes for GCP to provision the cluster.
All right. Mm-hmm. We only have 5 minutes. Almost. Because I have a meeting right after, so I would like to take a bite break before.
Yeah.
But now we are in our territory, right?
Yes, so this is the main page where I see most of the UX work being done here. So this is totally configured changes happening all the time on this page. On also the prior page as well. So when you go to Kubernetes, so this is our page as well, this is our domain. And now we have a list. Before we had just add Kubernetes cluster here in the middle. Now we have a list. If
so
you go to detail, ask.
Now you can see your Kubernetes clusters.
Yes.
Or other types, I guess. Or do we just have Kubernetes?
We are working on having AWS, but we don't have it yet. It's being worked on this release. So, sorry. It will be still Kubernetes, but it's Kubernetes on GCP or on AWS. And I think it will be some change on the UX right here, where we will be able to choose among, instead of GKE, which is Google Kubernetes Engine, we will be able to choose from EKS, which is EKS?
Managed Kubernetes Service.
But what's the E? Engine as well? Elastic Kubernetes. Yeah.
Why did Google make Kubernetes open source?
Why did Google make Kubernetes what? Open source?
Yeah.
That's a good question. I think they just, well, I can totally say to you that they are getting a lot of money from Kubernetes clusters on GCP.
That's why, probably.
Most definitely, yes. So let's see, how's it going? Oh, right now it's done. Okay, cool. So we don't have the loading anymore. So I'm going to try to be a little bit faster so we can finish this before 4. So we have some applications that are, we call them GitLab managed apps. And they are kind of plug and play applications that you can install on Kubernetes just like hitting the install button. So this first one is a dependency for all the other ones to be installed. And this first one is, so it basically means that the other ones will be installed by this one. So that's why we need to install it first. This one is called Helm, and it will run commands to install those applications on our Kubernetes cluster. That's how we communicate with Kubernetes is by using this tool here called Helm. So we first install it, and then we install Ingress. And Ingress is a load balancer that sits in front of Kubernetes.
Right.
So Ingress responsibility is to receive the request, and you can have many applications deployed to your Kubernetes cluster. And Ingress is responsible for this, defining which of your processes will have to respond to this request. So if I call app1 mykubernetes.com, it will send to the app1 service. If I call app2, then it will hit Ingress, and Ingress know that app2 goes to the process that handles app2. Okay. So that's like also necessary for us to, and it's also necessary for us to access the services externally, because it will expose an external endpoint for our applications. It's the only door open so we can talk to our services. It's through this Ingress. Right.
And you're talking about microservices, I guess, now. So yeah. It kind of orchestrate or directs. And you could also hit a service directly without Ingress?
It's possible, but not the way that we chose to do. You can open ports directly to the service. You can open tunnels to your machine that connects to the service. So you can create other kinds of load balancer that's not this specific Ingress. But yeah, you have some options. We decided to do Ingress. It's the most complete one, and it's a safe way to do it as well. So you see, now it has provisioned this IP, which is external. And we got to set, like when we enable Auto-DevOps, it said that we need to set a domain for us to access our services. And we're going to use this IP.
What is an IP?
I'll tell you. So nip.io, it's this website, this services, which is really cool. What it does is, if you request something to like 10.0.0.1 nip.io, it maps to 10.0.0.1. If you have 192.168 and all of this nip.io, it will send again to this IP. And then you can have also subdomains for more levels of subdomains .nip.io, and then it always sends your request to this IP, no matter what you put before it, right? So why this is cool? This works as a wildcard DNS, and what this allows us to do is to have many applications. I can have app1 and send it to my Ingress IP. This is the Ingress IP, right?
Right, and then it will send it to wherever it needs to go.
Exactly, and then it sends app2, it will also send to Ingress, and then Ingress will define where app2 and where app1 will go to, right?
So it will, yeah, put the port at the end instead of nip.io, or?
You don't need a port. You mean here? right?
Yeah.
No, it's listed on 80.
Ingress will substitute.
Yeah. You don't need the ports because Ingress is there. Exactly. And we basically use this for environments because we can deploy our application to staging, to production, to a review environment as well. It's another feature that we have. So we could have, for instance, here like a node app dash review, and then we can have node app dash staging, and then we can have all on the same cluster being, for instance, or different clusters, and the Ingress would be able to route to the correct path.
Cool.
Or the correct service. Okay, so saving the changes now. And this means that probably our pipeline has already been triggered by now. And I will just briefly talk about this other application. So this is just so we can have HTTPS on our application, not only HTTP. That's what it does. Prometheus is an application to collect metrics from our cluster. GitLab Runner, it's a runner that GitLab runs the jobs, the pipelines. It needs to have a GitLab runner to run those automated pipelines that we talked about. So either you have one of your own, you can install it on your cluster, or you can use the shared ones that are available for free on gitlab.com. Jupyter Hub is the application that I mentioned to you. That's the plugin that we can install on Kubernetes so we can have runbooks. Runbooks was the set of commands when an incident happened that we can automate. Mm-hmm. So this is what we use to...
For failure, safe
for failure, yeah.
Or something.
So when something crazy happens, we need to follow a set of commands, and then Jupyter Hub can automate those commands. And Knative is the plugin for serverless. It's what allows serverless on Kubernetes, right? So finally, let's check the pipeline. I will run another pipeline manually. I can explain you why later, but just so you can see. So we have two pipelines now. One was triggered automatically, and this one is more complete. But I want to show you the more complete one. So the more complete...
The manual one that you started right now.
Yeah, the manual one is this one. And what it's doing. So that code that we had on the template of the GitLab CIMO file, it would create maybe only 3 or 4 of those jobs. Each thing like this, section like this is a job that it's going to be run, right?
Right.
This is we call stages. We have the build stage, and we have the test stage, the production stage, and the performance stage. So someone would have to manually create a file that configures all those stages and all those jobs in that GitLab CIMO file. But Auto-DevOps did this automatically for you and configure a very complex, this is a very complex CIMO file that one would have to write. If I show you, it's like a set of files, not just one file. If I can maybe show you later. Or do I have it here? Hold on. So this is the file, and remember that template one was basically the same amount of this one or a bit smaller. But this one has very big files that are included inside of this one. So we're also creating jobs for security, checking the container, checking dependencies, checking license management. So each one of those is a different topic that does a different thing that you would need to be a very high-level developer to know all of it and to be able to automate all of it. So Auto-DevOps does this automatically for you.
Nice.
And you see the build job has already finished. Now the next stage kicks in, and now the jobs from the test pipeline will start to be run, and we'll reach the next stage when they all finish. Or if they fail, it will halt, depending on the configuration.
Right. I will need to stop you.
Yeah.
I'm afraid to have a 2-minute break and then join the UX weekly. But this was super interesting. Maybe, well, I can ask somebody else, or maybe we can have a small follow-up if you think you have more things to share, or for now.
I think we cover the most of what it is, the main things that we work on.
Cool.
Maybe what I encourage you to do, go to the Auto-DevOps manual on Google, just GitLab, and try to do it by yourself. And then if you have questions, then you can come to me, we can schedule another call. But try to implement this that I did today, since it's also recorded. Try to read this manual. I think it's, if you read this and you understand kind of what it's doing, it's, we are on a good way.
Great.
Okay.
Thank you so much, João. That was
No worries.
super, super useful. Sorry for asking so many questions. But
no worries. Yeah, I'm here if you need. Have a good day.
Thank you so much.
Bye-bye.
Have a good day. Bye-bye.